Alright, here's an actual homework problem that does the same thing as in the video, another video that I recorded today. I recorded 3 videos today, all of which will be right next to each other in the YouTube listing. And you probably want to watch all 3 of these if you're having trouble with this stuff, because it will get it more clear in your mind. So, on this problem, we're starting with the given. The given from right here is coming down here, and we're putting it over 1. That's the way we start all of our calculations. Now, this I didn't put in the unit of measure, so let's get that taken care of. Atoms of helium. So, that's what we put in here. Now, our next fraction is going to be helium atoms on the bottom again. Now, the fraction that we're going to use is going to be made from the 6.02 times 10 to the 23rd is equal to 1 mole. Now, since we're talking about atoms on the bottom, this is the side that has particles. And so the number that is with the particle side is the 6.02 times 10 to the 23rd. So we put in our 6.02 times 10 to the 23rd here. And the other side of this equation, or in this equality, is 1 mole. And that's what goes on the top. And the moles, again, are moles of helium atoms. Now, our last fraction is going to be done from using the number off the periodic chart. And when you look at the periodic chart, you're going to find this equality for helium. 1 mole of helium is equal to 4.00, I believe. And it is indeed 4.00. So, as I look up here, first of all, I had to cancel helium atoms as the unit of measure. Then I did moles of helium, not atoms of helium, and the number next to the word mole is 1, and so that's what comes down here as the coefficient to moles of helium. And the other side is coming from this, which is equal to grams. That equals 1 mole if we're talking about helium. And so this is a element-specific number. And so that's grams of helium. Oops. I messed up down here. And let's make this He instead of H2. Okay. So the moles of helium now again is going to cancel. And we're left with grams. And now we do our calculation just like we did in the example problem. And I'm going to do this with you on the calculator. So, as I did in the last video, I'm going to start with just the number and not include the power of 10. We're going to do that as a separate item. So we're just going to worry about this number, and this number in our calculator. So we'll start out with this guy, and let's go over to the calculator now, and we're going to put in the 3.40. Was that 40 or 04? 40. 40. And that's going to be times, is it going to be times? No, I don't think so. Let's go back here. You see that this number is on the bottom of the fraction. Because he's on the bottom of the fraction, he is going to have a divide. So we're going to hit the divide sign, and then we're going to put in the 6.02. Divide tells the calculator, I did 5, 6.02. That divide tells the calculator that the next number you're putting in is going to be on the bottom of a fraction. And now the next number that we're going to put in is going to be times, because this 4 here, right up here, is on the top of the fraction. And so that's going to be, as we do our input, 4.00. And then we hit the equal sign to get our answer. And that's 2.26. because I'm going to round right here at the 5, and I look at the 9 there, and that 9 is bigger than 5, so that will raise the 5 to a 6, and that would be 2.26. So let's go back and write that in. 2.26, and this is going to have the power of 10 stuff with it too. So let's do that part. We have 10 to the 22, and that number comes from right here in our calculation. And on the bottom of one of the fractions, we have the 10 to the 23rd. So I'm going to go ahead and put our 10 to the 23rd here, and since we subtract the bottom exponent from the top, we're going to wind up with 10 to the 1 minus. And now we have to go ahead and put that in, and we'll just put a circle around this so it doesn't get mixed up with the other number. This is times 10 to the minus 1, and the number is not in scientific notation, or it is in scientific notation. So we could leave it like it is, or we could just write it. Oh, wait a second, I moved that here. So yes, indeed, we just leave that there in scientific notation, or we could actually write the number, if we so desire, as 0.226 and leave out this power of 10. Either way is acceptable when we're talking about grams. Whoops, that's not a times, it's just the grams. So now we have grams, and if we're going to write it this way, we usually put a 0 here, and this is grams of helium. And that's your final answer. So that's it, folks.